Department of Computer Science and Engineering at St. Joseph Institute of Technology. And today we are going to begin one of the most exciting parts and most important topics is data analytics and visualization, graphical representation using Python MATLAB library. Now let me ask you something. When you see a large table of numbers, maybe sales for 12 months or exam scores of 100 students, how easy is to understand? Probably not very easy, right? But if I take the same numbers and show them in a line graph, suddenly you see the trend, sales are rising or marks are improving. If I show is at a bar graph, you can quickly compare categories. If I use as a scatter plot, you can immediately check whether two things are related like height and weight. If I show it as a histogram, you can see how data is distributed across ranges, like how many students score between 40 to 50, 50 to 100 and so on. That's the power of visualization. It transforms raw numbers into story your eyes can read instantly. And in Python, the most popular library we use for this is Matplotlib. It gives simple function to draw a graph, and we can able to draw professional quality graph in just a few lines of code. So today in our lab we are going to cover four major topics, which is line graph to show trends over time, bar graph to compare categories, scatter plot to visualize relationship between two variables, and histogram to see how data is distributed. By the end of the session, you will not only know how to write a Python code for these, but also when and why to use easy type of graph in real life. Let's start with the simple line graph. Alright, let's start with the very first type of visualization, the line graph. A line graph is one of the simplest and most powerful ways to represent data. It is used when we want to show the relationship between two variables over a continuous scale. For example, time versus sales. It helps to tell how sales increases every month, or distance versus speed. It shows how speed changes as distance increases. Okay. So what the line graph is, line graph connects data points with lines, and it also helps to best for trends over time. So in simple terms, a line graph takes individual data points and joins them with a line, so we can see the trend more clearly. So now let's see how to create a line graph in Python using Matplotlib. This code is really short, but let's go step by step. Okay. So we'll see step by step. The first step is we have to import the Matplotlib library. So I am importing matplotlib dot pyplot. So we usually give it as a short name as PLT. Okay. So the next step is we define our data. Here x is the x-axis and y is the y-axis. For example, x could represent data and y could represent the sale on those days. So here I represent 1, 2, 3, 4, 5 for x-axis, and for y I am mentioning 10 percentage, 12 percentage, 15 percentage, 18 percentage and 25 percentage. Okay, so here I represent x and y axis. Then the next step is the main plotting command. Okay, so first I want to type plt dot plot x comma y. It tells Python to plot the x values against the y values. Then I'm writing marker equal to O. It puts a dot at each data point. Then I am typing line style equal to hyphen. Okay, so it connects the points with a line. Then I want to make a color equal to blue. So I am writing color equal to blue. So here plt.plot x comma y tells Python to plot the x values against the y values. Marker equal to O. It helps to put a dot at each data point. Line style equal to hyphen. It connects the point with a line. And color equal to blue makes the line blue. So you will see the blue dots connected by a blue line. Okay. The next step is I want to add a title so viewers know what the graph is about. So here I want to add the title, plot dot title. It's a sample line plot. So it helps users to know what the graph is about. Then I want to label the axis. So labeling always help or explain what your data represent. For example, X could be time in days and Y could be sales in dollar. So here I am labeling X axis as X axis only. So here I can write anything, time in days like that, or anything, month or anything. And I can label Y axis as simply Y axis. Here also we can write anything. Okay. So then I want to draw a grid line. So I type plot grid, plot dot grid, true. So this syntax adds grid line. It makes the graph easier to read. Okay. Then finally I want to show my graph, display my graph. That's why I am writing plot dot show. So this helps to display the graph window. Until we call this, the graph will not appear. Okay. So let's run the code now. I'm running this code before I'm saving it. So see, we get a nice graph line with a beautiful circles connected by the lines. Now let me ask you, what happens if I remove the O, marker O part? What happens if I remove this marker O part? See, the circle disappear and we just see the line. So what if I change the color blue to color red? Exactly, the line becomes red. So by tweaking this option, we can customize our graph easily. So here if I change the color line as red, then I will get the graph as red color. Okay, so see, so that's the line graph. It's very useful when showing trends over time or continuous data. So in the next section, we'll move to the bar graph, which is better when we want to compare categories. So Now we will see the bar graph. Okay, now that we have seen line graph, let's move another very popular type of visualization, which is none other than the bar graph. Okay, so a bar graph is useful when we want to compare categories. Unlike line graph that shows trends over time, bar shows difference between distinct groups. For example, comparing sales of product A, product B and product C. Okay, we can compare sales of product A, product B and product C. Also, we can comparing marks scored in 5 different subjects. Also, we can comparing population of different states. So, bar graph helps to represents data with rectangular bars. It's also best for category comparisons. Okay. So, if you ever want to see which category is bigger or which category is smaller, the bar graph is the right choice. Okay. So, now let's see how to draw a bar graph using Python Matplotlib. This code is also short, but let's break it down line by line. Okay. So, now I am creating a new file for bar graph. The first step is I want to import matplotlib pyplot library. We call it as PLT so we can use it easily. Okay. Then we have to define our data. Here X is the categories and Y is the value. For example, if X were product numbers, then Y could be a sales of each product. Here simply I am representing 1, 2, 3, 4 and 5 and Y equal to product numbers. Here also I use product as 10, 12, 15, 20 and 25. Okay. So the next step is the main function for bar graph. So here plt.bar x comma y, which means we are plotting vertical bar for each value in x. Okay, so it means we are plotting vertical bar for each value in x. Then I will make all bar colors as green. Okay, that's why I am making color as green. So we could change this to red, blue or even different colors for each bar. So next I want to give a short, I want to give this short for a title. So plt dot title bar chart. So it always describe what the graph shows. Okay. Then I want to label the axis. So here I am labeling x-axis show categories. X label. Categories. Like it can be product names or roll number, and Y label shows the values like sales, score or population. So I am plotting Y label as values. It can be anything, sales, scores or populations. Then Finally, I want to display the graph using plot.show. Without this line, nothing will be appear. So I am going to save this code. As bar chart dot py. So let's run this code now. Matplotlib is the error. Matplotlib dot pyplot. Here I missed dot, so that's why it shows error. Now I run this. See, we get a 5 vertical green bars. Each bar's height represents the value, correspond to its value. Okay, so what if can I change the color to orange? Yes, if I change the color to orange means what happened? The bar turns to orange. Let's see if the bar turns to orange or not. Yes, this bar turns to orange. If X represents 5 products and the tallest bar of X equal to 5. Here the X represents the 5 product, the tallest bar is 5. What does that mean? It means product X has the highest sales. So the bar is your go to chart whenever you want to compare categories. It's simple, clear and effective. Next, we will move to scatter plot, which help us understand the relationship between two variables. Okay. So now let's move to the scatter plot. So far, we have seen line graph which shows trends over time and bar graph which compare categories. Now let's look at the another very important chart, the scatter plot. Scatter plot. Okay. So, a scatter plot shows the data points individually. Each point represents a pair of values, one from x-axis and one from y-axis. Why is this useful? Because scatter plot are great for checking relationships or correlation. For example, height versus weight. If we tell height versus weight means or taller people generally heavier, like that. Hard studied versus mark scored, that means do students who study more usually get higher marks? And the third example is temperature versus ice cream sales. It shows as temperature increases, do ice cream sales also increase? So these are the example, height versus weight for individual person, hard study versus mark score for individual person, temperature versus ice cream sale for individuals. So these are all the example. So the key point of a scatter plot is it shows individual data points. It shows individual data points. So for what it's best? It is best for relationships or correlation. It's best for relationship or correlation. So if you want to know whether two variables are related, scatter plots are the best choice. So now let's see how to create a scatter plot in Python with matplotlib. Okay. So here I am creating a new file. So let's see how to create a scatter plot in Python with matplotlib. Watch how simple it is. Okay. First I am importing matplotlib.pyplot. Okay, I'm importing this library. and call it as PLT. This is our plotting tool. Okay. Then I want to define our data. Here x-axis, x is the x-axis value and y is the y-axis value. So for each pair, x comma y becomes 1 point on the graph. So for each example, here 1, 2, 3, 4, 5, I take as the x-axis, and y-axis 10, 12, 15, 18, 25. Okay. Here for example 1 comma 10, 2 comma 12, 3 comma 15 and so on. We can take a value as pair. Okay. Then the step 3 is we have to use plot dot scatter instead of plot dot pyplot. Okay. Here I am using plot dot scatter. This draws the data as individual point instead of connecting them with a line. Okay. Plot dot data x comma y. So this draws the data as individual points instead of connecting them with a line. Then I am coloring it with the green, or I am coloring it with the red. Okay, so color equal to red, make all the points so red. You can try blue, green or any other color. Okay, then I am going to add a title. Plot dot title scatter plot. So we are already more aware of this. This tell the viewers what the graph is about. Then the fifth step is I am going to give the axis label. I want to label the axis. Plot dot x label. I just write as x axis, and plot dot y label. I am just writing this as the y axis. Okay. So here I am labeling the axis. Always explain what your x and y represent. Maybe x is the height in centimeter and y is the height in, weight in kg. It can be anything. Okay. Then the next step is I am going to add the grid line. So plot dot grid equal to true. Okay. This makes it easier to read or it is easier to see where each point fall. Finally, plot dot show display the scatter plot window. So now save it as scatter plot dot py and then run it. So I'm saving it again. Scatterplot.py. And I am running this again. See, we get 5 red points, each placed according to its x and y axis value. So we'll get 5 points. It placed according to its x comma y axis value. So a quick question is, what if the points were scattered everywhere with no clear pattern? So that means there is no relationship between x comma y. And another point is, if the points formed a straight upward line, what does that mean? It means X and Y has a positive correlation. As X increases, Y is also increases. So, the scatter plot is your tool to check relationship between two variables. So, it's simple, but it can reveal a very powerful insight. Okay. So, now we can try to another very important visualization, which is histogram. Another important visualization, which is none other than histogram. Okay. So, a histogram is different from a bar graph. While bar graph compare categories, histogram shows how data values are distributed across ranges. So think of it like grouping students by height ranges. 150 to 160, how many students fall here? 160 to 170, how many students fall there? 170 to 180 and so on. So instead of looking at individual value, a histogram helps us understand frequency distribution. How often values occur in different intervals. Okay. So histogram helps to find frequency distribution of data. So it helps to find frequency distribution of data. So it is best for continuous variable, best for continuous variables. So if you have mark, weight, age, have marks, weights, ages, salaries or any continuous number, histogram is the best way to summarize the data. Okay. So let's now write the Python code to create a histogram using matplotlib. I will explain step by step. Okay. So I am creating a new file for histogram. The first step is always to import a matplotlib library. Import matplotlib dot pyplot as plt. This is our plotting library. Then the next step is I will take our data. Okay, here I am taking just a numbers as 10, 12, 15, 20, 25, again 10, 12, 15, 18, 20. Okay. So imagine these are marks scored by 10 students. Okay. Notice how some numbers are repeat like 10, 12, these numbers are repeat. A histogram will count how many times each ranges of number occur. Okay. So next step is the main command plt.hist. So this is the main command plt.hist y tells a Python to create a histogram for the data in y. Then bins equal to 5. Okay. Bins equal to 5. Which means divide the data into 5 intervals or group. For example, if the number ranges from 10 to 25, each bin might cover about 3 point. 10 to 13, 13 to 16, 16 to 19, 19 to 20, 22 to 25 like that. Okay. So then I write this. Next I am writing color equal to purple. So it makes the bar color as purple. Then I am writing edge color equal to black. So it draws black borders around the bar, so they are easier to see. Okay, so here bin first plot.hist y tells Python to create a histogram for the data in y, and bin equal to 5 means divide the data into 5 intervals or group. For example, if the number ranges from 10 to 25, each bin might cover about 3 points. For example, 10 to 13, 13 to 16, 16 to 19, 19 to 22, 22 to 25. Then color equal to purple, which shows make the bar purple. And the edge color equal to black, it draws a black border around the bars, so they are easier to see. Okay, then I am going to add a title. This tells us what the histogram is about. So it's a histogram. Okay, then the next step is I want to label the axis. So plot.x label is it shows the ranges of values. So I am writing value range and I'm plotting y-axis. So it shows the how many values fall into each range. Actually, that is the frequency. So I am writing here as the frequency. Okay. So x-axis shows the range of values, which is bin, and y-axis shows how many values fall into each range. That's the frequency. And I am telling I want to draw a grid line. So here I am typing plot.grid equal to true. And finally, I want to display the histogram window. So plot.show. Okay, so finally I am display the histogram window. So let's save this. Save as histogram.py. Okay, now let's run this code. So here's the histogram. Let me ask you what happens if I change the bin from 5. Here you can see 1, 2, 3, 4, 5. 5 bins are there. So what happens if I change the 5 bins to 10? See, let us see what happens if I change the 5 bins to 10 bin. The bars get narrower because now the data is split into more intervals. Let us see what happens. See, the bars are more narrower and the data is split into more intervals. Okay, then what happen if I reduce the bin line as 2? Yes, exactly, the data is grouped into only 2 big ranges, so the bars are wider. So by adjusting the bins, we can control the level of detail in our histogram. So that's the histogram. So this is one of the most powerful tools for understanding data distribution. Whenever you want to see how values are spread out, like exam scores, income ranges, or age groups, histograms are the way to go. So with this, we have now covered up 4 main types of visualization. First one is a line graph, which shows trend, and second one is a bar graph, which is for category distribution, and third one is the scatter plot, which shows relationship, and the final one is the histogram, it shows distribution. So together these forms the foundation of data visualization in Python. So Alright everyone, let's take the last few minutes to quickly wrap up our today's session. We started with a simple question. How do we make sense of raw number? The answer was visualization. And today we learned four major visualization techniques using Python Matplotlib library. Each one has its own purpose. So let's summarize this. The first one, line shows trends, and bar shows comparison, and scatter shows relationships, and histogram shows distribution. So first the line graph, which is best for showing trends over time. Second, the bar graph, it's great for comparing categories like sales of different products. Third, the scatter plot, which is useful for checking relationship or correlation like height versus weight. And finally, the histogram. It is best for showing how data is distributed across ranges like exam score groups. So, visualization is not just about drawing pretty charts, it's about making data speak. It allows us to take raw numbers to turn them into stories that anyone can understand, whether it is a business manager, a researcher, or even a common person. Remember, use line graph when you want to see changes over time, use bar graph when you want to compare categories, use scatter plot when you want to check relationship, use histogram when you want to understand distribution. So, with these four tools, you already have the foundation of data visualization, and also we go forward, you will see how these combine with advanced technique to give even deeper insights.